Hello YouTube. Today we'll be covering another funny integral. We'll be covering the integral from 0 to pi over 2 of dx over 1 plus tangent to the square root of 2 power. So we take one look at this and wonder, how are you supposed to use calculus to solve this? Well, as it turns out, you do need to use a bit of calculus, but this problem is not as hard as you think. It's actually quite simple. So let's start off with doing some simple algebra. So we get pi over 2, 0. We can say that we know that tangent of square root of 2 power of x is equal to sine of x over cosine of x, both to the square root of 2 power. So we can say that this is dx 1 plus sine x over cosine x square root of 2 power. Now we can divide numerator and the denominator by cosine to the square root of 2 power. So now we get this integral, cosine square root of 2 power dx over cosine square root 2 of x plus sine square root 2 of x. Okay, so how do we proceed from here? Well, to proceed from this point on, actually steps are rather simple. So we can use a rather straightforward u substitution. U equals pi over 2 minus x. So we can get this new integral where we can transform the bounds. So we get pi over 2 minus 0 equals pi over 2. We get pi over 2 minus pi over 2 equals 0. New bounds from pi over 2 to 0. And then here we can know one really important trig identity. So we know that cosine of x, cosine of pi over 2 minus x is equal to sine of x. Similarly, sine of pi over 2 minus x equals cosine of x. So if we raise them to the n power, we get a new set of identities. Cosine to the n power pi over 2 minus x equals sine to the n of x, and sine to the n pi over 2 minus x equals cosine to the n of x. This works because we're just raising equal numbers to the same exponent. So we can change any cosine into sine and any sine into cosine. So let's do that. We get sine to the square root of 2 x, or no, u du, because remember du is equal to negative dx, so we actually have a negative up here. Then we'll have sine here plus cosine here. So this is equal to this. So now if you can do a simple integral transformation here. So we know this property from calculus that if you just flip it like this, if you flip an integral, or if you flip the bounds, it becomes the negative of itself. So we have b here, a here, f of x dx. So here, similarly, we can flip the bounds here and say that this is equal to negative of this integral, 0 pi over 2, because we're flipping 0 pi over 2 to 0 pi over 2, like this. So then we have negative sine square root 2 u du over sine square root 2 u plus cosine square root 2 u. Okay, so now where do we continue? Well, we can cancel out the signs, so negatives cancel out. So I'll just say that the negatives, they cancel out this way. So this integral here is equal to this integral. So if we add these two integrals up, so let me just get rid of this. We can say, let me just bring this to the top. Cosine square root 2 of x dx over cosine square root 2 of x plus sine square root 2 of x. So if you want to visit one of the steps again because you couldn't catch it, then you can just go back in the video. So this is equal to 0 pi over 2 of sine square root 2 of x dx equals to cosine square root 2 of x plus sine square root 2 of x. And both of these are equal to I. And both of these are equal to the original integral that we wanted to find. So this is also equal. So we can add these two up. So we get I plus I. So we'll get pi over 2, 0, cosine square root 2 of x plus sine square root 2 of x dx over cosine square root 2 of x plus sine square root 2 of x. And that actually just becomes the integral from 0 to pi over 2 of just 1 dx. So it actually simplifies out quite nicely. So this just becomes pi over 2. So we conclude that 2i equals pi over 2, which would lead to our final answer of I being equal to pi over 4. And that's our final solution. Okay, thank you for watching this YouTube video. It was actually rather brief considering how weird this integral looked at the start. I hope you check out my next video if I post another one. See you.